Good day. I am Jay Manzano Moica, and I'm going to discuss the topics on the fifth week of the fourth quarter. And our topic for today is tests on population proportion. At the end of the lesson, you as a learner should be able to formulate appropriate null and alternative hypotheses on the population proportion and identify the appropriate form of the test statistics on the population proportion when the sample size is large enough to invoke the central limit theorem. Okay, before we start our lesson, let us review first steps of hypothesis testing. First, formulate the null and alternative hypothesis. Second, identify the test statistics to use. It includes the level of significance and the critical value. And then, using a simple random sample of observation, compute the value of the test statistics, then make a decision on whether to reject or fail to reject the null. And lastly, state the conclusion. But how should we formulate those hypotheses? First, identify what is asked, then determine whether it's a one-tailed or two-tailed. Okay, so let's have an example. The principal of an elementary school believes that this year there would be more students from the school who would pass the national achievement test, so that the proportion of the students who pass the NAT is greater than the proportion obtained in the previous year, which is 0.75. So, what will be the appropriate null and alternative hypothesis to test this belief? Is for us to formulate the null and alternative hypothesis, we should first know what is asked. In this problem, the parameter of interest is the proportion of students of the school who will pass the NAT this year. In symbol, the parameter is denoted as P or proportion. As applied to the problem, the appropriate null and alternative hypotheses are as follows. For null, the proportion of students of the school who will pass the NAT this year is equal to 0.75. In symbol, HO is P is equal to 0.75. For alternative hypothesis, the proportion of students of the school who will pass the NAT this year is greater than 0.75. In symbol, HA is P is greater than 0.75. Why it's greater than 0.75? Because the principal wants to know if the NAT this year is greater than the previous year. And our last topic for the week is to determine the test statistics. In our problem, the variable as to whether a student passes the NAT this year or not is said to follow a Bernoulli distribution with parameter P. If we further say that out of n students, the number of students who will pass the NAT this year as the variable of interest, then this variable is distributed as binomial with parameters n and p, with the assumption of large sample to be able to invoke the central limit theorem. The appropriate test statistics denoted as J of C is computed as J of C is equal to P hat minus P sub 0 all over the square root of P sub 0 times the difference between 1 and P sub 0 all over N, where P hat is the sample proportion computed from a simple random sample of N observation, and P sub 0 is the hypothesized value of the parameter. The test statistics follows the standard normal distribution, which means the tabular value or the critical value in the Z table will be used as critical or tabular value. So that's all, and thank you. Good luck and God bless.